So in 1999, the house was worth $180,000. In the year 2009, it was worth $245,000. We want to write a function v of x, where x is the year, to estimate when the value of the house was worth $219,000. Along the way, we want to know, what does the slope of v of x represent? Here, we need to take a look first at what we're given. And in this case, we're given two ordered pair, 2 points, if you will. You see, they told me two things. In the year 1999, a home was worth $180,000. Based on that, I can make an ordered pair. X is the year 1999. Our y value, in our case, v of x, that's the value of the home, $180,000. Our second point comes from the fact that they told me in the year 2009 the home was worth $245,000. So I have a second ordered pair. X is the year 2009, and our value for that year, the $245,000. Now we assume that the growth in the value of the house is going to be constant. We know it isn't constant every year, but in the long run, we have here a constant rate of change. Because we have a constant rate of change, this is what we can use to calculate a slope. We have our general slope formula. Slope y2 minus y1, x2 minus x1, our change in y divided by our change in x. For us, the y values were the value of the house. $245,000 minus that initial $180,000 divided by those x's were the years. 2009 minus 1999. So we have for our slope the rate of change in the value of the house, $65,000, divided by the change in the years, which was 10. And keep this in mind, our numerator was measured in dollars. The denominator measured in years. This will matter. For us, we have a slope m of 6,500. Now, because we have a slope and we have points, let's use our point-slope form in order to make our linear function. The general form for the point-slope form, we could use y is equal to m times x minus x1 plus our initial value for y1. So we want a function v of x. Our v of x now is equal to our slope, 6,500, times, for x1 and y1, I'm going to use the initial values of the house. So x was the year 1999, y, the value at the time, $180,000. Now, because we're going to be doing work, solving some problem with this function, it may be beneficial to change the form. We have it now in point-slope form. What we could do is rewrite it in slope-intercept form. Our old y equals mx plus b. It's going to require that we use a little distribution first. So our v of x will become 6,500x minus some ungodly large number, 12,993,500, plus that 180,000 initial value. So we have v of x equal to, finally, 6,500x minus 12,813,500. Now, this doesn't look nice, and it's not very pretty, but it will do the work we need. You see, we want to know, when was this house worth $219,000? So now we have the tools we need to solve the problem. To solve, we really just want to solve the linear equation. When does 6,500x minus big number, 12,813,500, equal to $219,000. And yes, these are large numbers, but the fact is we were working with X being a year here. And so that's going to lead to large numbers. Solving our equation, not terrible. Solving a linear equation, we can add a value to both sides of the equation. And so we're going to have 6,500x equal to $13,032,500, and finally, blissfully, dividing by that 6,500, we have that x is 2005. So all that means is, in the year 2005, this is when the home was worth $219,000. Now we did have a second question. It asked about what does the slope of v of x represent. Keep in mind what the values were. It is positive. Because it was positive, this is an increase in the value of the house. And remember what units we used earlier. The numerator was measured in dollars, the denominator was measured in years. So, we can say that the home increased on average. After all, we don't know that it was exactly the same every year, but it increased on average by $6,500 per year in value.